Alright, ladies and gentlemen, this is 6-2 notes, finding side length of a right triangle using sine of x or cosine of x. Objective, you'll be able to solve for a missing side length, giving a right triangle with a reference angle and one side length. Now bear with me, I'm not the best photographer here in the world, so we're going to be zooming out, zooming in a little bit. So stay there to the best of your ability. Try your best to follow along, okay? So, this is 6-2 notes with me, Mr. Brzezowski. So zoom out a little bit so it's nice and pretty. So first, let's make sure our graphing calculator is on the right mode. Meaning, we have to make sure our mode is in degrees when we're doing sine of x and cosine of x and solving for a side length. So step 1, turn on the calculator by hitting the on button, located in the bottom left-hand corner. Next step is hit the mode button. This mode button is located next to the second button, so it's in the top left-hand corner. Next to your second button, hit the mode button. Step 3 is scroll down using those arrow keys on the right-hand side, top right-hand corner. Scroll down to where you have radians and degrees. There's a black box highlighting radians. What I need you to do is scroll over that black box and then hit the right arrow key. So the black box is now on the degrees. Then hit the enter button. So step 4, the black box should be highlighted on degrees. Hit the enter button to make sure the black box is on the degrees. Then I need you to hit second mode, which is your quit button, and I'll get you back to the regular screen that you're used to seeing. Then what I want you to do is type in SIN button, just like we did in class, which is located about 4 buttons down and 1 row to the right. SIN button. Then type in 15, close parentheses, enter. And you should get the answer of 0.2588190451. If you get that answer, that means you programmed the mode correctly. Alright, let's move forward, because you could always rewind on the video if you want to try that again to make sure. Alright, so next slide. Below is a right triangle with a reference angle and one side length. Our goal is to solve for the missing side length x. So you notice here in our triangle, the angles that are on the inside of the triangle, the ones that are not 90 degrees, these angles are considered the reference angles. It's your starting point. Remember how I emphasized starting point in class? So this is where we're going to start. So from our 15. Now from our 15, the farthest side away is our opposite. So our x is located in our opposite in this problem. That's why I wrote our opposite is x. Now across from the 90-degree angle will always be our hypotenuse. So this number 12 is our hypotenuse. And our reference angle, once again, is this 15 degrees. That's our starting location. To solve for this side length, what we use is sine, cosine, or tangent. But today we're just focusing on sine and cosine. And let's do an example problem. So here on our next slide here. So we'll zoom out. Hopefully it shows up a little bit more clearly on your screen than it does mine. When we're given an x value in our opposite and our number is in our hypotenuse, like we have in our triangle here, x is the opposite of the 15 and 12 is the opposite of the 90-degree angle, aka 12 is in our hypotenuse. When we have this type of setup here involving an opposite and a hypotenuse, we set up our equation just like this. Sine of the reference angle, which in this case is 15, is equal to the opposite, which is our x, divided by our hypotenuse, which is 12 in this problem. We're going to set up our equation just like this. To get x all by itself, we do our inverse operations and we multiply by 12 to both sides, so we get what we see here in number 2. 12 times sine of 15 is equal to x. Now, since x is all by itself, we have our calculator in our degree mode already. We type that in right into our calculator. 12 times sine of 15. Hit our enter button. And we're going to get 3.105828541, which I believe in a lot of worksheets they say round to the nearest hundredth place, so it would be 3.11 or simply 3.1 if it's rounding to the tenths place. And that's one style problem. We're going to go over 4 different types of problems here. So next, let's talk about when the x value is in the hypotenuse. We're going to do the same type of setup here. However, what's different is that our x is now on the bottom in our fraction. So let's walk you through it. When we're given an x value in our hypotenuse and a number in our opposite, we then need to follow these steps. So we set up our equation, sine, because we have an opposite in the hypotenuse, of our reference angle, which is 47 in this problem, is equal to 30 divided by x. So anytime when x is on bottom, all we got to do is just flip-flop the x and the tangent function here. Or the trig function, pardon me. So we flip-flop it like we do here. So x is equal to 30 divided by sine of 47. We do this so our x or our variable is all by itself, because we want to isolate it to get x equals. So we type in our calculator, 30 divided by sine of 47. We hit our enter button, which we do down here, 30 divided by sine of 47 is equal to 41.019823, so on and so forth. AKA 41.0 is perfectly fine here. Or 41.02 if it's the hundredths place. So that's what happens when an x value is in the denominator of the fraction, aka on the bottom of that little fraction. Let's do another problem here with cosine. So in this case, when we're given an x value in our adjacent, aka it's on the bottom here, it's not in the opposite, it's in the adjacent, and a number in our hypotenuse, we need to follow these steps. So we're going to have to use cosine, because the cosine involves adjacent and a hypotenuse. So cosine of our reference angle, 25, is equal to x adjacent divided by our hypotenuse, so x over 12. To get this x all by itself, we multiply by 12 to both sides, so we get 12 times cosine of 25 is equal to x. Now that x is all by itself, we type that into our calculator. 12 times cosine of 25, enter, and we get 10.8756, so on and so forth, aka 10.88 or 10.9. Those are all correct answers here, depending on what we want to round to. Let's do one more problem here. We got cosine, once again, because we have an adjacent, a number in the adjacent, and a variable in our hypotenuse. So that's where our 2 locations where our numbers or variables are, according to this reference angle. So we do cosine of 47 is equal to 30 divided by x, because it's adjacent, divided by hypotenuse. Since x is on bottom, we're going to flip-flop these two to get x all by itself. So that's what we could do from here to here. X is now by itself, so we do 30 divided by cosine of 47. We type that into our calculator, 30 divided by cosine of 47. Hit enter, and we get 43.988. 3 gibberish. We round it. We could round it to 44. We could round it to 43.988, so on and so forth. Now, what gets a little tricky is that our pictures aren't always going to look like right triangles like we have here. And our reference angle, depending on the location of our reference angle, it could change up the problem quite a bit. So notice here in our 4 problems, our reference angle is always here in the bottom left-hand corner. If I change that 47, I put the reference angle now up here, the 30 is now in our opposite position, and our x is in our hypotenuse. So since it involves opposite hypotenuse, that means this problem here is a sine problem. Sine of 47 is equal to 30 divided by x. Now if that 47 is up top and our 30 is now located over here on this right hand side of the triangle, well, according to this reference angle, the 30 is in the adjacent position, and x is in the hypotenuse. Since we have adjacent and a hypotenuse, that means we have to use cosine. So this one will be cosine of 47 is equal to 30 divided by x. So the location of your reference angle does matter. So that's why it's always best to label on the worksheet or copying down the problem on a notebook to label your opposite, your adjacent, and your hypotenuse. And once you label it, then you know which one to use, sine, cosine, or tangent, when typing in the trig functions in your calculator. And we can solve the problems just like what we did here in these 4 scenarios. Alright, if you have any questions, please feel free to email me. I'll be happy to help you out. Or come to Extra Help or anything like that. Alright, have yourselves a wonderful day. Good luck. Bye-bye.